Welcome to a short podcast on how to assess normality. So assessing normality turns out to be kind of a big deal. In many cases, the test of hypotheses that we're going to use run under the assumption that the underlying data that we're assessing is normal. Okay, so we have to do something about checking that assumption. So there's a couple of ways of doing that. Okay, one of the easiest and best ways of doing it is what's called a normal quantile plot. And I'll leave the details of how this plot is actually constructed to you to look up in the book, or you can send me an email and ask me about it. But basically what it does is it takes your data and forms what are called the quantiles, and it plots the quantiles on the y-axis and your data on the x-axis. And if that plot looks close, or pretty close to a straight line, then that plot indicates that the data are normally distributed. If you have systematic deviations from a straight line, that indicates non-normal behavior in your distribution. Outliers are going to appear as points that are far away from the overall pattern of the plot. So that's a really nice, simple tool, and it turns out our calculators do that plot. Our TI-83s, 84s have this plot built into them. Now, another way, of course, is to look at the histogram. If we see sort of a bell-shaped distribution, then that's a really good indication that we have a roughly symmetric or normal distribution. So let's go ahead and take a look at three sets of data that we've collected. One set is from the face-to-face class, that's the age data. We'll take a look at that, and then we'll take a look at our left-hand and our right-hand data from LDI 4.23 back in Chapter 4. Okay, so let's get into our calculator. And I have these data all up here in the editor where you can see them right now. Not necessary to have those open in the editor in order to be able to do the plots, but it's just nice to know what I'm talking about here. So I'm going to go in and go second, plots, go into stat plot. I'm going to plot 1. I'm going to turn that plot on, and then under plot type, I'm going to go all the way to the very last plot type that's available to me. And that very last plot right there, that's the normal quantile plot, or the QQ plot as our textbook calls it. Hit an enter, and then the only thing it wants to know from you is where does your X list live, or your data list. Your data list is the list that you're trying to assess normality on. Okay, so let's go ahead and look at this plot, and we'll do a zoom and the number 9 to do a zoom stat. And what we notice is that it would probably be a bad idea to use a normal distribution to model the age data, because this does not look like a line, it looks like it's curved. Okay, well, let's see how that's backed up or collaborated with by looking at the histogram from the age data. Well, if you recall, we've looked at this earlier, that histogram was skewed to the right. Okay, and sure enough, there we go. It would be really a bad idea to go ahead and use a normal distribution to model the set of data. Okay, let's contrast this with our right-hand data. So let's go take a look at a normal quantile plot. Actually, we'll start off with a histogram for the right-hand data, because we have not looked at that yet. So scroll down here for our X list, and let's change that to RH for the right-hand data. And we'll do a zoom and the number 9. And we see an approximately sort of bell-shaped curve here, okay? It doesn't look like there's too much deviation from normality here. It's just roughly symmetric is what we would say, okay? So let's see what that looks like with respect to our QQ plot. Okay, so we'll come down and again select the very last plot type that we can select in our list here, and we'll do a zoom in a 9. Notice our data list is still RH, and notice we get roughly a linear pattern. Notice that the data all falls pretty much onto a line. So that's a very good indication for us for normality. Okay, all right, now let's go take a look at the the left-hand data. A little bit of a change here. Go take a look at the histogram. We'll start off with that. And we'll go down here and we'll change the RH to LH. And again, looking at the histogram first, we'll do a zoom and a 9. And you go, I don't know, what's going on here? Let's change our window a little bit, okay? Notice we're going from 35 to 141 in increments of 17, okay? So let's go ahead and let's go from 35 to 141, but I want to go in increments of 5, okay? And let's change this to 140 just to make it work right, so that we're in nice units of 5. And let's try that graph. Now, I've broken it up to let you see that you notice that you've got some outliers over here, don't you? And then the first histogram we drew, it wasn't too obvious to see where the outliers were. Well, those outliers have got to be who? Well, think about it for a minute. That's the folks who were left-handed, right? You may not recall this LDI, but this is where we're Xing out the boxes, right? Okay, so we've got some definitive outliers. Looks like there's 3 of them roughly in here that differ vastly from the rest of us. Now over here, this group, if you were to come and cut it off like right here, you would have to go with roughly symmetric. There wouldn't be a lot of deviation from normality there, although it's awfully spread out. It's hard to say skewed. Maybe a slight skew to the left, but basically you'd have to go with roughly symmetric. Okay, so let's see what the QQ plot would look like in this case. In this case, when we go down and take a look at the QQ plot, we're hoping that our QQ plot identifies the outliers for us. So I've got that selected. Yep, there we go. Do a zoom and a 9. And sure enough, there you go. See, our 3 outliers that showed up in our histogram show up as very different from the rest of our distribution. The distribution that does not include those outliers looks like a line would probably do a good job of modeling the situation. But these 3 data points, which are outliers, show up as distinctly different from the rest of the pattern. Okay. So, hopefully that's a good introduction to the whole idea of normalcy and maybe or maybe not, but how to determine normalcy using a histogram and a QQ plot. See you back here for the next LDI.